2021 SnowEx Hack Week. And that's coming up in about a month, I guess. It's coming up fast. July 12th to 16th, we'll be getting together again with the larger group of folks. This is a subset of people for our week-long event in July. This is the first time that we're doing a Hack Week for the SnowEx program, so we're really excited about that. I want to thank all the amazing tutorial leads and people who have come together and putting in a lot of effort to create some content to share with you here in about a month. One of the reasons why we're offering this session is the goal of our Hack Weeks is to bring together everyone into a space where we can learn about open science tools. And when we do that in a Hack Week, what we find is as we're teaching folks some of the fundamental tools like GitHub and Python, it's made a little bit easier for us to teach that in advance so that everyone comes to the Hack Week kind of more at the same level, and we can get started on the specific content for SnowEx a little bit more quickly. So our goal is to create these spaces for everyone to come together and collaborate regardless of their skill level. And that's why we wanted to offer this session to those folks who may be starting off in their journey of learning open science tools. Maybe you haven't worked with GitHub before. This is a great chance for us to get together a little bit in advance to get some practice, get some skills down, and then you can continue to refine those as we get together into this larger group. So that's kind of the thinking around what we're doing. This is the first time we've really done this in advance of a Hack Week in this way, so we'll welcome your feedback on how to continue to improve this as we go along. Here at the University of Washington, we're offering these Hack Weeks in a variety of formats. And as we do so, we're really dedicated to creating these welcoming learning spaces. One of the ways that we do that is through adhering to a code of conduct. And I put the link to the code of conduct right at the start of our Slack channel today. I encourage you to have a look at that. At that link, which is on our SnowEx website, you'll find the description of the code of conduct, as well as ways that you can raise any of your concerns or ask questions through a variety of resources, either talking to one of the lead organizers or various different contacts here at the University of Washington, because this is a UW sanctioned event. So please don't hesitate to contact us if you have any questions or concerns. This code of conduct will apply to our interactions in all of our virtual spaces, on Zoom, on our Slack channel, in anything that we're doing as we interact in this work. And hopefully we'll get together again in person one day, as we see in these photographs here. I want to thank the University of Washington's eScience Institute Hack Week program, all the people that are helping to build this program together. This is not a software carpentry event specifically, however, we're drawing heavily on the great software carpentry trainings that are available. We'll be teaching sort of a subset of that today and tomorrow. And then the NASA Terrestrial Hydrology and SnowEx program are funding all of our efforts here in the coming month. All right, quick logistics is we're using Slack. It looks like most of you have been able to get on there in the Software Carpentry Questions channel. We'll use that for asking and answering questions. If you have a question as we go along, throw it in the chat, and then one of the helpers will jump in and try to provide some answers and guidance on that. And often we'll do that in a thread. You'll get a feel for that as we go along. It's nice to kind of combine things in a thread so that each topic is together. It is most convenient to download the Slack application. Go to the Slack website and grab that if you haven't done that already. If you're able to, that is. I know some folks may be at federal institutes where that's not allowed. So you can also access Slack in your browser. But if you have any trouble getting onto that, just let us know. We use Slack because it's more persistent, and the Zoom chat is a little bit more ephemeral, and it's it's harder to kind of manage answering of questions. All right. Well, one of the goals of our Hack Weeks is to kind of build networks and connections among all the participants and the instructors. And we have pretty limited time here. And this next 2 days will be a little bit more of a training than it is a Hack Week per se. And so there'll be, a little less chance for interaction, but we wanted to create a bit of a space for us to start to communicate. We've already done that a little bit in our Slack channel. And what we thought we would do is HP and I would begin a conversation together, just to share a little bit about our journey delving into the open science world, in the hopes that that will prompt some additional conversation. So keep your Slack channel open, and as HP and I have a little chat here, just go ahead and type in whatever comes to mind, anything that might bubble up for you, any sort of reflections and musings that come to mind. Maybe sharing a little bit about where you're at or what you've discovered as you've gone along and learning some of these tools. So that's the goal here. We'll talk for about 5 minutes or so. I'm starting off with this picture of HP at the 2017 GeoHack Week, I think, where so these GeoHack Weeks are a little bit more broad topics, but this is an event where HP and I had a chance to connect a little bit more. And HP, I just wanted to ask you about that experience and kind of what first attracted you to joining a Hack Week. My understanding, chatting with you back then, is that you obviously had written a lot of code and done a lot of programming over the years, but you were fairly new to the open science kind of way of thinking. Is that right? Tell us a little bit more about what attracted you to come to this event.
Yeah, I guess one of the big ones was, so I've been using MATLAB since I was in high school, which I'm going to date myself, kind of back in the 90s. And it's been hard for some of the, students that I've trained in MATLAB when they leave the university. The access to that expensive software platform makes it harder to share what you're doing. So I really like the idea of this sort of open source movement. One of the things that attracted me to it is one, that people take away a tool set with them wherever they go. But this sort of community effort, having everybody working together and able to share code and interact. And I guess one of the things that really attracted me was, I think in science right now, a lot of our opportunities have to do with the networks that we have, and in particular, like who our advisors know. And that has to do with both access to software as well as access to data. And so I guess that's maybe the thing that attracted me to it the most, is that it's an approach that gives everyone equal access. And again, with all of the conversations around diversity, equity, and inclusion, this seems like a really powerful tool for broadening our community.
Yeah, definitely. So that was 2017 when you started down this path on the Hack Weeks or so. Tell us what's changed in your work since then. What have you noticed, either in your work specifically or within the communities and networks that you interact? Have you seen anything evolve over that time period?
Yeah, so I was at this 2017 one, and then I came to the ISAT 2 Hack Week in 2019, and just watching some of the platform, the different software that's really getting to a point where lots of people can use it. I have to admit that, in my role right now at this point in my career, it's been a challenge for me to switch completely over to a new software package. I think my students are a lot farther along on that path. Probably the biggest thing that I've adopted is just software version control. So the Git stuff that we'll be learning about has been a really powerful tool. And now we've been working on building this open science database using SQL for SnowEx that hopefully will create some momentum with this group here to keep using this this shared database that will allow a lot of powerful searching across lots of different data sets.
Nice. Okay. What was it like for you to learn Git and GitHub? Was that the first time you saw it when you stepped into the Hack Weeks?
Yeah, it was. So I definitely came to both 2017 and 2019 as a student. And it's hard. Git's not very intuitive. It's a super powerful tool, and I'm still doing a lot of learning.
Yeah, so am I. Anything else you wanted to say, HP, like about what you're hoping participants will get out of, especially the next couple of days before we launch into our work?
Yeah, well, I mean, I really like this idea of having a dedicated software carpentry leading up to Hack Week. It's overwhelming, like a lot of the stuff that I think all the participants will see in Hack Week. It's so much new information. I think that's really great because people come in at a really wide range of sort of programming skill sets. So there's something for everyone to learn. But I think a little bit of instruction now and then some practice, hopefully, before Hack Week starts. I think everyone will get a lot more out of the Hack Week itself. And again, I'm hoping that this helps motivate a community within seasonal snow in particular, which I think that we have a long way to go in terms of being really inclusive and open and sharing software and data. And I'm hoping that this creates some momentum in that direction.
Excellent. Well, thank you. HP will be one of our helpers today. And we want to thank you, HP, and especially just for kind of guiding the process and design of this event over the last, well, many months, over a year. We've been talking about this. So it's really great to see it all coming together. The lead instructor today is Joe Meyer, who's going to be guiding us through our first day of work together with helpers Scott Henderson, Naheem Abdesi, and I want to give a shout out to Jane Coe, who's done a fantastic job sort of on all the logistics and administrative work to get us to this point. And Jane is helping us in a variety of ways today as well, with sort of Zoom logistics and breakout rooms and all those great things. Did I miss anyone? I know we've gone back and forth in our design of this, who's going to be helping out today. Please just jump in and let me know. All right. Any other announcements before we hand it over to Joe? All right, I'm going to stop sharing. So Joe is a graduate student at the University of Utah and has been heavily involved in the Hack Weeks over the years. Really appreciate, Joe, all of the time you've poured into this, and looking forward to your tutorials today. So I'll hand it over to you.
All right, well, thank you for the introduction there, Anthony. Like I said, I'm at the University of Utah, and been also attending Hack Weeks personally to get first connected to them. And then I guess I got so hooked that I couldn't stop participating or helping out. So I also think it's a really cool environment to build and set up as a whole, as being a researcher or being, an open source contributor, and can advance a lot in the science. And today, I would really like this to be as hands-on as possible. So if people have the opportunity to put up, 2 screens on the monitor, or I don't know how your technical setups are, please really try to follow along as we talk and speak, and also raise a hand if you have trouble following along, because it's really important to us that you get every point we want to deliver to you, and then also, you don't fall behind and feel like you can't catch up anymore. So really raise your hands. We have helpers, we have Slack. Really use those tools as you can. So you will see, let me look at me to the left, because I have a dual monitor setup as well. So I'm not kind of ignoring this right-hand camera there. It's just a matter of how my setup is here. Anyhow, so we'll start today to get you connected to our JupyterHub, and which will be the central tool we will be using throughout the next 2 days to learn all these things that Anthony just mentioned. And to get started there, I will start sharing my screen. This one. So I hope everyone can see that, and if you need a bigger font size, let me know as well. So first of all, to get started, did everyone get an invite to GitHub and was able to create an account? Because this will be the fundamental first step we have to get everyone past. So if you're not, please raise it in the Software Carpentry channel, and say if you had trouble getting a GitHub account. So far, I see no immediate reactions, which is good. And then the next step after that is, so you see, this is the list of members that are currently in our Hack Week. And in order to access our JupyterHub, you need to ensure that you have, like Anthony up here, a public membership of this organization, because this will enable you to log in to the JupyterHub. So the way you change it is basically you go to the SnowEx Hack Week organization, which Scott, thank you for posting that. in the Slack channel just posted the address right there, the people. And then all you really have to do is you open this little flyout here and you change it to public. So, and once you do that, you can then use as a next step this little link that's here, JupyterHub, which is the SnowEx.hackweek.io. And there, if you click on that, then you should be redirected here to the JupyterHub. So it will take maybe like a minute or two, or a little less, like you saw right here. And if you see the screen that I'm seeing here or showing you as well, then you have like successfully set up your connection, also the public kind of membership. And now that you're here, this is our JupyterHub. So this is the environment you will be using the next 2 days and also throughout the entire hack week, and where you're gonna edit the code or download tutorials or like follow along. And also, most importantly, I guess, is also deliver the projects, because this is the environment that we provide for you to ensure that everybody is technically set up the same way and has all the access to the libraries that we'll be teaching you about and you'll be using. If you've never seen this before, I'm going to give you like a slight introduction today, and I think Scott will have a little more in depth tomorrow, because it's going to be a little more focused on the Python side tomorrow. But for today, I want to just give you a quick kind of what you can do here and what we're going to need today. So you see up here, this is kind of like a standard desktop environment. You have like different flyouts menu, and this here is called the launcher. So up here you see on the tab, this is where you can open a notebook. This is, like I said, a Scott topic for tomorrow, or a console. We're going to open a terminal. So this is the most important part for today, which we will be using, the terminal right here. And then you also can do various other things we're probably going to be utilizing as well. It's like adding in a text file or adding a markdown file. Over here on the left-hand side, this is like a file browser like you have on your own computer. And once you would have files showing up under your home directory, this is also would be showing up here. Also, first up, everyone, as he logs in, has its own personal space there. So this is really your space, and I don't know quite the limit there, but there's a certain size limit, so you can't just upload terabytes of data. And we also ask you please not to. But you have a good amount, like a couple, like 10, 20, 30 gigabytes for sure that you can use there. And you can do there whatever you want, and no one will be able to access that. So this is really your space that you have throughout the whole week and also today. So you see we have 15 people logged in right now. I'm going to keep talking a little more and describing it, but please right now go ahead and raise if you have any issues accessing it. Because the next tutorial that HP is going to be leading about the terminal itself will be using that. So we need to make sure right now that we have people logged on there, and any other kind of technical setup issues may be resolved right there. So right now, as I said, today we're going to use a terminal. So to open a new terminal, it's a you're going to click there with a single click, and then you see this launcher here, switch to a terminal. And this is, if you haven't seen it before, this is a standard Unix terminal where you can type in commands, for instance, like we do right now. I'm going to just list the content, and you see it says total 0, which also is reflected here on my left-hand side, which is the file browser, that I do not have any files there. If I want to go back to the initial one that I showed you before, this is when you hit this plus button up here, which says new launcher. So if you maybe remember from earlier logging in, if you hit the launcher here, you're going to get as you would have just logged in. And you can launch as many tabs as you want to help you kind of organize your work. And one of the nice features I also encourage you to use is, like, since this is a JupyterHub, you can split things around. So I'm going to do this again. If you just hold your mouse button down, you can organize them in a way you want. So you can now have two terminals open at once, which could be helpful, for instance, if you would be adding in multiple files, or you would do simultaneous actions. And then you can really just, by holding and dragging them across, organize them the way you want it. So this can be very helpful for today, because we're going to be using terminal and also editing some files. So I could highly encourage you to have like two setups here. Do we have anybody that has still issues? I see there's a few in the chat. When you see a 400 or 403 errors, this is most likely to a public. So you haven't switched your GitHub profile. I can go back to that site here. So you go to what Scott posted in the chat, is the people page of SnowEx. Then you're going to look for yourself in the list here. I can demonstrate this with my personal account. If I can find myself, this is me. So here you see I have set a public, which is what we need. And out here, this is how you change it. So if I would have this showing private, you would not be able to log in. What else do we have? 403, yeah, this is the obscure number that's a high indicator of needing to switch to public. Yeah, a good point is raised in the chat as well. If you're all doing this at once right now, so this is a dynamic cloud environment. So every time you log in, there will be a new instance, what we call it, spun up for you. An instance being having all of this, what I showed you right here in the Jupyter lab, being like started up as an environment for you. So it will take a minute or two if we do that all at once. But once you're set up, you're good. So there will be not any lags in the process after that. So I do see right now I'm hitting my 9:25, which we want to be on schedule for today. Does anybody have a question so far, maybe that is about the JupyterHub?
I have a quick question.
Yeah.
So because I'm a little bit lost.
No worries.
I'm using because first of all on the Zoom I don't have a way to post my post a chat. I don't have a way to start a chat. Is that?
Oh, so we were not going to use all of Slack today for that question.
Okay, so on Slack, I log in Slack. That's right. Opening 3 things. So which one? I don't really see the chat on the Slack. I'm new to Slack.
So in Slack, I can also try to, I'm going to stop sharing. If you downloaded the application locally, let's share it here. So if you're new to Slack, you will be starting something like this, and you see those channels here on the left, which I joined. And if you don't have that, you can go to the channel browser, and then in here you can type in Software Carpentry, like software. You see, and now you can. This should be filtered, but I guess for me, since I'm already a member, or you can scroll through them. So this is the way you can join channels. And here we have your Software Carpentry questions. This is the one you want to join.
Oh yeah,
This is also your issue?
Yeah, I'm in.
Okay.
Cool. Okay. So then, yeah, I'm still lost with the GitHub to make myself public.
Correct.
So people or go to people, right? Okay.
Yep.
All right. Okay. I get it.
I can go back to that page. Anybody else? I think there was some technical things that Scott fixed for us. Thank you, Scott, for that. Okay, there's more things being resolved. Okay, and then for people who maybe just got in for the first time, I'm going to quickly repeat again what I said before. If you now hopefully have a new screen here, let's do this. You probably have something that looks like this. And again, here you have like a top menu bar as you're used to from launching an application on your local computer. And here also you see you could either launch a terminal there. Or as I said before, we have a launch panel here, where you just can click and we'll switch us right to there. You also have the option to launch multiple of those. So this is one of the beauties why we like the Jupyter Lab environment. You can have multiple tabs being launched. And for the ease of sake, I'm just going to do another terminal here. And then again, for today's tutorial, and also I think maybe for tomorrow might be helpful, you're able to split those and have them showing up at once. So here I just hold down my mouse over this terminal, and then I can start dragging it around the way I want it. And I highly encourage for today, I think when HP goes around, and also later for the Git session that I do later, that you kind of experiment with a good setup. Having multiple really helps to follow along multiple times there. And to repeat, this on the left here is something like you would have on your computer, where you see files and folders. I guess I can demonstrate it quickly. This. Oh, mistyped it, that's all right. But you see it's also showing up here right now. And this is the now, like you have a right click there as well, where you can do actions. And since I, for instance, when I say mistyped it, I can rename it right here as you're used to it. Now you see it's fixed. And then later on, if I say I don't want this anymore, I can also delete it. And I get a nice confirm dialog to say, okay, do you want this? So there's also a little fallback there. As a heads up, if you have a folder and you want to delete a folder in there that still has files, it will ask you to first make sure that the folder is empty. So it's kind of a little caveat to know. All right, well, let's see, we don't have any more questions or issues. I mean, HP, do you want to get started maybe on the Unix side, or should we give people like another 5 minutes to spin up?
Yeah, I mean, I can just start a little bit slow and maybe people can post questions in the Slack box.
Sounds good to me. Stop sharing my screen now, it's all you.
All right. So I'm going to try sharing my desktop. So I'm in the middle of a trip right now, so I don't have an external monitor, and maybe some of you don't either. So I'm going to try just 2 separate windows, and maybe you can try to do something similar on your end. All right, so can everyone see my desktop? Does that look okay? Should be able to see the welcome to SnowEx Hackweek.
Looks good.
Site. Okay. So just another couple quick things on just navigating here. We're going to be going through some of the preliminary work, and so that you can, in particular, this software carpentry training. If you forget how to get on the JupyterHub, hopefully people are getting that spun up. But under that preparation, if you click on JupyterHub, you'll have the link there just for you to be able to find that in the future when you log back in. So we're going to go to software carpentry training here, and we're going to be in this section just covering topics 1 to 3 on the Unix shell. And so what we're going to just go ahead and click on that Unix shell. And 1 to 3 is, I mean, we're starting kind of at the beginning. So for some of you, this is going to be a lot of review if you have worked on the command line quite a bit, but it is going to be a necessary skill to start to develop for Hackweek. So we're going to spend some time just on some of the basic functions and approaches to using the command line. There is a setup section right at the very top. And so I thought it's not in this, but just a quick way, since we are working in the cloud on this JupyterHub, just to give you an approach for how you might download the data that goes along with these lessons. So at the top of this Unix shell setup, there's under number 1, it says download shell-lesson-data.zip. And because we're in the cloud, we're not going to be able to just drag that over to our desktop. So what I'm going to do is I'm just going to copy that link. So you can, I'm on a Mac, so I'm going to do Control, click, and then copy link address. You could also do a right click if you're on a Windows machine. So I'm just going to copy that link there. Just one other comment. as you start to build your skills working with the command line, there are ways of doing this outside of the cloud too. So I just wanted to mention those real quick. If you're on a Mac, your terminal is built in. So if you go into applications and utilities, you can find a local terminal there. If you're on a Windows machine, there are a bunch of software programs out there to give you a command line. Git Bash is one that I would recommend. So I'm going to click over to my terminal here. And again, just like Joe showed, and I forgot to give a big thanks to Joe. He's put a lot of time into this. So thanks again, Joe, for really stepping up here, as well as everybody else that's from eScience Institute that's helping to organize this, and all of the tutorial leads and other folks that you're gonna meet as we go through the software carpentry material. So I'm gonna click on terminal here, where this is where we're gonna be working for this tutorial. So hopefully everybody's able to get to a terminal window here. And the first command we're gonna do is called wget. So we're just gonna grab the data from this link. So now that I've copied that link after wget, we're getting a file from the World Wide Web here, and we should be able to see that that gets downloaded onto our local directory here. We're going to go through some of these other commands. One of the first ones that we're going to go through is ls for list the directory of our current working directory. So you can see we've got a zip file here. You can also see it in the file browser to the left. And what we need to do is that package has been zipped up. So a bunch of files that have been packaged together, and we're going to use one more command called unzip to unzip that file. So we're just going to type unzip at the command line here. And then the file that we want to unzip is this shell lesson data. One of the nice things about the command line is you can use tab completion. So if I hit tab after typing shell, there's only one file or folder in that directory that starts with shell. And so it fills that in for me. And I would really recommend trying to use that tab completion as much as you can. It's not just faster, but it makes sure that you type things in correctly. So I'll go ahead and hit enter there. And now I've got those files. And let's bring this up here. So now I have a directory called shell with all shell lesson data that has the files that we're going to need for this lesson. So that's really the main thing from the setup. We don't need the other steps because we're working in the cloud and we already have our environment set up. A big thanks to Scott for doing that. I'll just pause for any questions, and if helpers can take a look at the Slack, that would be wonderful as well. So we are going to start with just a real short one, introducing the shell. What is a command shell and why would I use one? Then we'll move into navigating files and directories, and then working with files and directories. There's kind of a couple big advantages to working with the command line. If you haven't worked this way before, maybe you've used a graphical user interface and have clicked through different folders. And so we're going to just kind of talk about how we do that from the command line directly. The main reason why there's a big advantage to doing things this way is that we can automate tasks. So instead of, as you kind of read through the lesson here, and again, we're not quite going to have time to go through all of the details on all of these lessons. So hopefully this gets you started, and then you'll have these lessons as reference. This approach does allow you to automate things. So one of the examples they have here is if you had to do things many thousands of times, working with a graphical user interface is something that you would have to do a whole lot of mouse clicks over and over and over again, and would take a much longer period of time. So that's one big benefit. It's easier to not make mistakes when you go through all those point and clicks. It's easy to do something slightly different some of the time. And then the last advantage is that what you do is then repeatable. So big advantages to working with the shell, even if it's not super intuitive to start with. So we've started our own terminal here, and we have our prompt, which is everything, including this $sign here. And it's telling me I'm this generic user here It's got my username here, and then I can start typing commands at the $sign. And when the screen gets a little messy like this, we can type clear just to get rid of everything above. And so I guess the main points here are that you should be able to see after the $sign a flashing cursor. That's the position where your typing is going to appear. And we're going to jump right in. When we execute a command, it's always going to be at this command prompt, and then we're going to have to hit enter afterwards. So we're going to start with our first, well, we've done wget and then unzip, but now we're going to get into kind of poking around in these directories. So we'll start with an ls command, which is just short for the listing of the directory. And so when I type that, you can see I'm getting the same information that maybe you're more familiar with on the left-hand side in sort of a GUI type interface where I've got some folders and I've got this new directory that I've also created there, as well as the zip file that I originally downloaded. Okay, now there are lots of different commands and sometimes we might type things wrong. So as you can see, the example here is ks. And then bash is the shell that we're inside of. There are many different terminal shells. We're going to be working with bash, and it's telling me that the command is not found. So that's usually just a prompt that maybe you typed in the command wrong and had a typographical error there. There's a sort of a typical problem that they describe in terms of how somebody might deal with having to manage a whole bunch of different files that you need to run a specific script on. So this goostats.sh is a script that this example scientist wants to run on 1,520 different files. And so we're going to be talking about how to build towards being able to do that in an automated way. So that's kind of the real quick just introduction to the shell. And now we're going to move into the second part, which is going to be navigating around the directories. So I'll just take a quick moment to look at the chat or at the Slack here. Get rid of, there we go. Okay, it looks like we've got, I think we're good, yeah. Okay. So back to my screen here, we're going to go up one in these little tutorial sessions, and we're in this second part, navigating files and directories. We're going to go through a little bit of material here. We've got, if we go through everything, it's about 30 minutes with 10 minutes of exercises. I'm going to try to group the exercises into one block, and we'll get into breakout groups for a quick hands-on there where you can interact with some of your participants or co-participants. Okay, so some of the things we want to tackle here are, how do I move around on my computer in this way? And how do I see what files and directories I have? And how can I specify the location of a file or directory on my computer? And so we're going to start with this command that stands for print working directory, or PWD. This is one that gets used quite a lot. So we'll go ahead and just type that in at the terminal, and hopefully you can follow along as well. So the present working directory that I have here, and this should be the same for you, is /home/Joven. And so what we're looking at there are these forward slashes are separating directories. The very root directory is going to be that very first slash, and then we're inside of a directory called home, and then inside of a directory called Joven, which is our sort of default username. So that tells me where I am. This would be similar to in a GUI sort of file browser, clicking into those specific directories. Okay, so there's a nice sort of diagram here of what that file system might look like. Again, on Macintosh computers and on Unix and Linux computers, that's a /. On a Windows machine, that's going to be a \. But so we have our root directory here. Underneath that root directory, we have 4 different folders: bin, data, users, and temp. And again, we can use this approach to define where we are in that hierarchical file structure. So what we're gonna get a little bit more comfortable with this ls command. So pwd again is print working directory. That's how we can tell where we are at any given time. And so that any program that we run will be able to access the files in that directory unless we specify otherwise. So again, we'll go back to this ls command. That's another one that gets used all the time. So I get this sort of list of the file folders and files in that directory, but it would be nice to have a little bit more information. And so ls has a bunch of options, which are also known as switches or flags. And we choose those options by starting with a hyphen. So we're going to try one of the first options, and then we'll talk about how we actually figure out what these different options do. So the first one we're going to test here is we're going to try ls minus capital F. And one thing to just be aware of is that these options are case sensitive. So make sure that you're using a capital F and not a lowercase f. And it's telling the current directory contents, but to add a little marker that indicates what they are. So a trailing / is going to tell us it's a directory. An @ symbol is a link, and we may get to that later, but that's probably a little beyond scope. And then a star is an executable that we'll eventually be using when we're working with shell scripts. So if I do an ls minus f, I'm going to get, again, just a slight bit more information. That / at the end of the directory or of the name is telling me that that's a directory, as opposed to a file, which is the zip file that we downloaded. Okay, so and then again, this covers how to clear your terminal. If you want to bring things back to the top and be able to see things clearly, that clear command will just get rid of everything above. We still can use the up arrow, and that up arrow is a useful way of scrolling back through our previous commands. And the last one that I use a fair bit is history, which just lists all the commands that we have made previously. Sometimes you want to repeat a command, and this is a way of kind of getting a list of what you've done so far. Okay, but how do we get a little more information about how to use a bash command or a command within the terminal? We're going to be using this -- help here, and that's going to give us more information about the different flags that are available. So if I type ls -- help, I'm going to need to make my window a little bit bigger so it's a little more readable. But now we can see that we can scroll up here and see all of the different arguments that we can actually choose to use. And so we're going to get a little bit of practice using a few of those that are some of the more useful ones to add to an ls command. But for your reference, that -- help is a great place to start. If you're on another system and where the manual pages are installed, you can also type man ls. That's not currently on this server right now, so use the -- help for just size reasons. I think we don't have that installed right now. But two approaches to get more information. Again, it's good to be able to get used to identifying some of the issues when you're trying to start working with the terminal. So if we type ls and then minus some option like J that doesn't exist, we're going to get invalid option. And that's, again, it's prompting us type ls minus help for more information. One of the things that I find with both myself and with students is getting really frustrated when an error is created, and it's really helpful to try to get away from that gut reaction and really focus more on the information that the computer's giving you when there is an error. You'll see that as we get into the Python, getting good at troubleshooting some of those error messages is really, really important, and that would be the same for working with the terminal. Scrolling through here, so we've got a couple ways to explore in a little more detail, and I think I was going to group this one with the next set. So we'll just kind of do this together, this first exercise, and then we'll get into a breakout group for the next exercise. So what this exercise is asking for is trying to use two options at the same time. So we're going to do an ls, and we're going to add a couple different options. So a -l, not to be confused with the number 1. So that's a lowercase l, and the -h option. And I'd encourage you to just try using the ls -- help to scroll through here and look at, well, what does -l tell me? So it's a long listing format. So let's go ahead and try that first. So I'm going to type ls -l. And now what I can see is I have a little even more information here. I've got my directories. All of this information on the far left is telling me both whether it's a directory or a file in the very first line, and then more like what are the permissions, who's allowed to execute this file or read and write this file. And then we have in the numbers here is the size of the file and then when it was last modified. So we get a bunch more information that can help us in the future. And then the -h option, with these options, we can either do -l -h, or if you want, you can just do -lh. And all that's doing is it's putting the size of these files in what they call a more human readable format. So now these are all in terms of kilobytes. If I had files that went up to gigabytes or more, they would be separated with those just to make it a little easier to see the file sizes. Also, sometimes it's useful to list our files in reverse chronological order, because many times we're creating files and then we want to see if we were successful in creating those files. And that could be in a directory that has a lot of different files within it. And so we can do that with an ls -r, and and -lr gives us that extra information. So now this is in reverse alphabetical order. And if I add a T to it, it's going to be reverse chronological order. So now you can see that the this first thing that we downloaded is actually June 5th, 2019. And then all of the other files are newer and newer in time. So a couple ways to use ls. Again, encourage you to look at that in more detail. And then exploring other directories. So we can apply this ls command with those flags, but we can apply it directly to a directory without moving into that directory. So in our example here, we created this directory called shell lesson data. And if I wanted to, I could do an ls command and maybe with this -rt because I want to put it in order, but then I can apply that to a directory. So I'm going to type shell and then try to get in the habit of using the tab completion. That really is going to both speed up your work, but again, prevent you from making misspellings when you're trying to type a directory name. So now when I do that, I can see that I've got a bunch of stuff inside that directory. Oops. I can add an L to it to get a little more information, and even a capital F if I want to see, oops, which ones are directories. So again, that capital F gave me the / at the end, making it a little easier to see which are directories. And then I've got things in reverse chronological order. This is now within this directory shell lesson data. I can double check that by typing pwd. So you'll see I'm still in the directory that I was in before, just this home directory. If I, so that's again, just covering that you can look inside of directories without actually moving to those directories. Okay, so that's how to sort of see what we have in our different directories. We're very often wanting to move through the file structure, much as we would if we were double clicking on folders within a Finder window. And so the way we do that is with a command that is called cd, which stands for change directory. And so we're going to use cd to change directory into this directory that we created from the data that we downloaded. So again, ls -f gives me a list, and I want to go into this directory shell lesson data. So I'm going to type cd for change directory, and then I'm going to start typing shell lesson data. But now in this case, we do have two files here. We've got both the folder and then we have the zip file. And I just want the folder itself. So I want to make sure I don't have that .zip on the end. And I hit return. And now you can see not only have I changed directories, we can test that with, again, pwd. And now you can see that my directory is home, Jovian, and then shell lesson data. And if I did ls-f here, I would get this list of folders and files that I found from before, but now I'm actually sitting in this directory. Okay. Now there's the last thing that we'll do before we get into some exercises here is there are two special directories that we don't normally see. They're hidden when we do our typical ls command. And so what we're going to do is we're going to add one more flag. And this flag is a -a for we want to list all of the files or directories. So ls -f -a. So now you can see there's two extra directories that occurred here. One is dot, and there's a slash because it's a directory, and the other is ... And those have very specific meanings. The // is the current working directory. So that's the current directory that I'm actually in. So sometimes that's useful to be able to really specify I want to start a path from the directory I'm currently in. Sometimes when we're executing files, we'll use a ./ and then the executable file name to make sure it's executing that specific file. The one that we'll use the most is this double dot. So 2 dots and a / means one directory up. So let's just practice that. We're going to say change directory ... Okay, that's going to bring us back to our original home directory. And again, use that pwd command to bring you back to that present working directory. So that's just backing up. It's like going backwards from entering a directory. We're coming back up into one higher directory level. There are some other hidden files. So that -a, what that did was it also showed you files and folders that started with a dot. Often configuration files and things start with a dot before the name of the file. And maybe, it's not useful to always see those, but that -a will show you all of the files and folders that do start with a dot. If you're in your current working directory, you may see a .bash profile, which is kind of setting up some of the defaults in your bash environment, but that's probably a little beyond scope of what we're covering right now. This tutorial covers a little bit on orthogonality. The basic idea there is that .. is not just defined for the ls command, it's defined for any of the commands that you might use. So whether we're changing directories or listing the contents of a directory, ... always means the directory one level up. So we can try that. ls by itself is the directory that we're in right now and should agree with our folder browser to the left here in the terminal. And if I do ls ... that's going to be what's in the directory one level up. So that would be what is in the directory just home, one level above where we currently are. Okay. So we can then also add, you can go more than one directory at a time. So I'll cover that and then we'll get into an exercise in breakout groups. So if I wanted to move through a number of directories, I could change directory to one level up. Now I'm just in this home directory. I could change now back into my own home directory, this Jovian, but then I could include after that / the next level of directory that I might want to enter. And if I remember that this shell directory is the next one down that I want to go into, I can move basically 2 directories down at once. So if I do that and then type pwd, I should see that I'm in home, Jovian, and then shell-lesson-data. Okay. There are two other shortcuts that they cover that are worth knowing. They make navigating around in the terminal window a little bit faster. The one is the tilde character, so the little squiggly line. And if we put that at the start of a path, that will start me in my home directory. My home directory is this Jovian directory, the place that I end up when I first log in. So if I was buried in this directory here, maybe I'm one level down in data. So I'm several levels up or several levels within my home directory, and I want to go to a folder that, or maybe I want to just see what's in my home directory. I could do an ls tilde. And what tilde really means is you can think of tilde as replacing /home/ your username, in this case, Jovian. So it's just a shorthand for, instead of having to write out that what's called an absolute path that we're going to cover next. And then the last shortcut is a dash. And what the dash does is return you to the last directory that you were in. So in this case, I'm sitting here at shell-lesson-data and then a folder underneath that called data. And I could type cd tilde. Again, that's going to change my directory back to my home directory. So if I do that, now I'm at my home directory. Again, try to practice using this pwd command to verify what directory you're in. And if I wanted to go back to where I was before in that shell lesson data, and then within that folder called data, I can type cd and then just hyphen. And so cd hyphen just took me all the way back to where I was the last time I used that change directory command. Okay, so a few important commands here. We've got cd, we've got ls, and we've got pwd. Those are probably the three that you want to kind of focus on if you've never worked in a terminal before. And now we're going to go into an exercise. So we're going to go into a breakout room, and you'll have maybe 4 people in your breakout room. Make sure you post if you're having trouble into the Slack channel, and we'll have a helper jump into those breakout rooms. And so hopefully you're here within this lesson. We've got a couple exercises: absolute versus relative paths, relative path resolution, and then reading comprehension. And those 3 should kind of help you get a feel for how to move around in the various directories. So I'd encourage you to try to make this hands-on and do that. And if you already have used the terminal a ton and this is all review, please try to help your fellow students in your breakout room. So I guess I'm going to ask Jane, maybe if you could open up some breakout rooms so that we could through these exercises. Okay. Well, hopefully everyone got a chance to practice some of those commands from the terminal window. We're going to do a little bit more of that. Everyone see my screen okay?
Yeah, looks good.
Great. So I'll just go back here briefly. We've gone through now the first 2 lessons here. We got the data files we needed from setup. We introduced the shell and talked about navigating files and directories. So for our remaining time, we've got about 15 minutes left before we take a break, where we'll take a formal break at that point. So we're going to just cover what we can from this working with files and directories tutorial here. And so this is going to cover how do we create, copy, and delete files and directories. And then we may talk a little bit about editing files. Okay, so creating directories. So we're going to look a little bit more into detail about exploring files and directories, which is what we just covered. But now how do we create them? So we're going to go back into that directory that we created from the file that we downloaded. So again, an ls can tell us where we are, and we're going to change directory to get into this shell lesson data. And let me make this a little bit bigger. Okay, so we've got all of these directories and then a few files inside there. Our PWD for present working directory can just verify that we're in the directory that has the data associated with this lesson. They give another example using that capital F flag, which is just going to put that / on the end of the directories to distinguish them from the files themselves. But now we might want to create a new directory. So that's the next command. And the command is mkdir for make directory. And we're going to create a directory called thesis. Okay, so now we've created this empty directory called thesis. Again, a -F should show that thesis directory exists. And this might be a case if we had a lot of files here that we might want to do that -RT and then capital F and maybe with a lowercase l as well, which will stick that directory we just created thesis right at the bottom so that we know that we're successful making that directory. Okay, we might want to just verify that that it is actually an empty directory. So an ls -F and then the name of the directory we want the listing from. So the first command is ls. Then we have a option or a flag that starts with a dash and then has a letter that's going to do something specific. And then the third thing is basically our input to that function, or what directory do we want the list from. And so what we can see here is that nothing is returned. That's an empty directory that we just created. There's also a -P option to that make directory if you need to create multiple directories at the same time. So the example they have here is creating, make this a little bit bigger, creating a directory called project, but then within that directory, a subdirectory called data. So we do -P, we're just saying we're going to create multiple directories, project data. That's our first directory, and our second directory is going to be called project results. So again, we want to make sure that this worked. So an ls -F, we should just see a new directory called project. And if we want to look at what's in project, there should be two directories within project, both data and results that you can see there. One more, just introducing another flag to that ls command that's really useful, the capital R option. So what the capital R option does is it's recursive, and so it is going to list not just the directories, but their subdirectories. So we'll try that here. ls -F capital R project. And so now we can see within project, we've got directories data and results. Within project data, which is then the next level down, we don't have anything, and we don't have anything in results yet either. But that capital R is a very useful tool for looking at not just what's in your current working directory, but in the directory levels below. Okay. They have some good notes here for how to name files and directories. Probably one of the most important ones is don't put spaces in the names of your directories. This ends up happening quite a bit on Windows machines when you're using a GUI, and there is a way to make it work from the command line using a / to take that space character literally, but it typically always creates typographical errors and problems. So really try to avoid using any sort of spaces in your folder and file names. Try to use dashes instead, but also don't ever begin a name with a dash, and just stick with letters and numbers or a period, a dash or an underscore in your file names. Okay, so they do cover a little bit on how to create a text file. For our purposes, if we do need to create a text file, you can go to the File menu at the top of your JupyterLab interface, New, and then Text File, and then that's a pretty straightforward way of generating a text file when you get to that stage. There are a number of different editors. The one they describe in this lesson is called Nano. VI is another common one. Emacs is another common one. Those are a little bit beyond scope of what we're going to cover today. They type a little more text in their example. I did want to point out just, you know, I really like the text that they use here. It's not publish or perish anymore. It's share and thrive. I think that is really at the core of Hack Week, that we're not competing against each other. We want to work as a team, and we will all thrive if we do so. The control key is important when you're working through some of these tutorials, just sort of how that's described. It's either a C dash or a caret or a CTRL. Those are sort of, they have a list of different ways that that might be described, but all of those mean the control key. Okay. So let's see, we're going to skip sort of making things from the Nano because we're not going to use Nano. So now we want to talk a little bit about how to move things around. So maybe we've created a directory and we've put some stuff in it, but now we decide we want it actually located somewhere else. In a graphical user interface way, we might drag that folder. In this case, we're going to use the command move, or MV. So let's first, what we're doing here is they've created a little text file called draft. I'll just use one of the tools that Joe went over just to describe it, since he did do that. Is we'll go into our thesis folder, and we don't have anything in there yet, but let's create a file in that folder. One tool for creating just an empty file is this command called touch. So we'll use the command touch to create a file called draft.txt. And what touch does is it just creates a file. And if we do ls-l, ls-l, you can see that it has 0 bytes. So there's nothing in it. It doesn't contain anything, but the file itself does exist. So we could append information to that file. If we wanted to move that file, maybe a simple way of moving it would be to just rename it. That can be the same thing if we're just going to change the name of it rather than moving it into a different folder. So we could type mv draft.txt, and maybe we want to call it quotes.txt. And we can do an ls-l to check. Again, this is all practice, and the more you do this, it'll get more and more comfortable and familiar. So now that draft.txt doesn't exist anymore. We've effectively renamed that file from draft.txt to quotes.txt. So that's one thing that we can do. We can move things around that way. We can also move files to a new folder. So we maybe could create a new folder here called draft1. And we might want to move that quotes.txt into that folder. So I would type MV for move, and then quotes. And again, note that I'm using that tab complete because there's only one file within this folder. So I could just type QU and then hit tab, and it's going to find, it's going to suggest basically the file that starts with those letters. And now I want to move it to this folder that I created called draft1. So again, I just type DR and then tab. And you can see it already extended that. And the important thing to recognize here also is that /. So that just confirms for me that I'm not just renaming it to a new file called draft1, but that is a directory. And so it's going to move that quotes.txt file into that draft1 directory. So now I should just have one thing in my thesis directory, which is this draft1. And inside that draft1, I should have this file called quotes.txt. So again, we introduced just a recap there. We introduced a few new commands. One useful one to get used to again is history, right? We can kind of look back, what commands did we apply? So in this little section, we used mkdir, make directory. We explored how to use the -p flag to create multiple directories at once, and did an example of where we can create a nested structure of directories. So we can create one directory and then another level down. We're working with this ls command some more, and in particular, this capital R allows us to kind of see within those directories. So maybe we'll just do that example one more time. If I go back a directory, cd ... moves me up one. And note that I'm also getting information about where I am right from the prompt here. So there's various ways of setting up your prompt. The default here is set up so that you can actually see your present working directory right there in the prompt. Remember that we covered that the tilde is shorthand for your working directory, your home directory. There's even a shortcut to getting to your home directory by just typing cd with no inputs at all. So just cd by itself brings me right back to my home directory. You can see it's just tilde is there. pwd tells me that home directory is /home/Jovian. So what I might want to just remind myself of here is that ls followed by a minus capital F, capital R is going to break down all of these different folders. So it's one way of looking at things in a little more detail. And we had a lot of different folders buried here, so I might have to scroll up quite a bit, but you can see it kind of outputted each individual folder and then what's inside of that folder. Okay, so we've got a couple minutes left. Let's talk a little bit about how to copy files and directories. That's probably the next most important tool that you might need to use. So often it's useful to make a copy of a file if we want to edit it but preserve the original one. Git is going to be a much better way to handle that kind of those kind of changes and being able to revert to previous versions that Joe's going to cover shortly. But we do need to know how to be able to copy files. So let's do an example of how to copy a file. So we'll go back to our directory that started with shell lesson data. And inside shell lesson data, we created this directory called thesis. So I'm inside again, this little prompt here is telling me where I am. Present working directory can always verify that for me. I'm in home, Jovian, shell lesson data, and then thesis. And let's say that I wanted to copy that, that file into maybe either another file, maybe I just want a second version of it. So I've got this file, oh, I put it in draft one. Let's go ahead and move it back down. That's a good example. So if I go into draft one, I've got this quotes.txt. Let's put it back where it was before. So I can go move quotes.txt. And now the move command can also use that ... So I'm moving quotes.txt one directory up. So now that quotes.txt shouldn't be there anymore. I can now move one directory up. So cd ... and then another ls. Now I've got that quotes directory there. One of the things that I may want to do is now copy this. I could either copy it to just another file. I could copy quotes to quotes 2. This might be something that you might do if you don't know how to use Git. Hopefully we'll get to where we can use Git and not have to just have lots of versions followed by a version number. But that would be one example of the copy command. Maybe I want to copy an entire directory. So let's go up one directory level. So now I'm in shell lesson data, and let's copy that entire thesis directory. So I've got this directory called thesis. Let's copy thesis into something called thesis 2. Okay, now I get an error, okay? And I didn't use this specific flag called -r. So again, -r is referring to something that's recursive. If I want to copy the entire directory thesis plus everything underneath it, I can use a -r. So copy -r thesis, and then I'll follow the tutorial here, thesis backup. Okay, so now that should have copied both the folder as well as the file that was in it. So let's just double check that, ls -f thesis backup. And you can see that I've got that subfolder draft 1, I've got quotes 2, and quotes are all contained within that new copy of that folder. Okay, so renaming files. If we wanted to rename, again, we kind of already covered that. If you misspell a file, you can just use that move command. Moving a file from from its current name to a new name is equivalent to just renaming. Let's see if there's anything else here. Removing, let's do removing, and then we'll end this session. So often we do want to delete data, but one thing to keep track of in a Unix environment, there's not like a trash bin. So when you remove something, it really is gone forever. So you want to be really careful with the remove command. Again, remove is just RM. So we can practice that here. We'll go into this thesis directory and let's remove that second version of quotes. So we're going to do RM and then quotes, and I want the second one, quotes2.txt. So that's just a way of deleting or removing. So RM for remove. Now you can see that's gone. What if we wanted to remove the folder draft 1? So I could remove draft 1. Now it says it's a directory, right? So it's preventing you from deleting an entire directory. That's really just protecting you from deleting a whole bunch of things that you don't want to delete. It is possible to still remove that entire directory with the -R recursive flag, but again, be very careful. If you use that remove -R command, it's very easy to accidentally delete an entire directory structure. And so they do point to one other flag here that's useful, which is the -I flag. That stands for interactive. And so if I did remove -I, well, let's do quotes first. So it's just going to give me a prompt. Do I really want to remove this file? And then I could either say yes or no. So it's sort of an extra check to protect yourself. We could do a -I, -R to this directory draft. And that'll again give me that prompt. I can hit yes. And now I've deleted that directory draft along with everything that was potentially underneath it. So again, be really careful with that remove command, especially if you're using it with the -R flag. There are some other exercises and for operating with multiple files and directories, in particular using wildcards. I'd highly recommend reading through that star feature for using a wildcard to be able to really narrow down the lists that you're generating, as well as doing things with multiple files is very powerful, but it's just a little beyond the amount of time that we have here. So I'm going to go ahead and stop there. Hopefully you've gotten a little bit of an intro to the Unix environment, and I think we're on break now. Maybe someone can verify that for me. Looks like it. Okay.
Sounds like we're good. All right.
Yeah, I think we're good.
Wrong headphones.
I was wearing the wrong headphones. Were people talking to me?
No, I just use like to myself.
It's funny. I have two computers running.
Yeah, like I said, do you want to have any announcements, or should I just kick it off?
No announcements.
All right.
Take it away.
All right, cool. Well, welcome back, everybody. Hope you had a chance to stretch your legs, get a snack or a drink. And before we kick off with the second round, I would like to encourage folks, if they have time afterwards today, to also set up their Slack account. So I see a lot of folks have joined today for the first time and maybe don't know much about Slacks, but we would like to really use it also as our community tool. And in there, we then also like to see your full names, and if you have a chance, also a picture, because it really also goes back to the point I think that Anthony raised earlier, said, and HP said as well. We want to build a community, so it's nice to have like a face with a name, like a full name, and then maybe who knows, you're going to meet each other in some conferences or anywhere out in the field, and then hey, you're able to associate someone better, I think, than having all these like weird acronyms we always use, right? Okay, cool. So I will cover Git with you for the next, I guess, a little less than 2 hours left with this. And Git, before I start with that, I'm going to start to share my screen here. So Git as a whole is not just like a Unix command I want to show you today. It's also the same way a concept of how it enables us many ways to make our life easier, and also version controlling of documents. I almost had to giggle a little bit when HP showed the example earlier where we started to, you copy things around version 2, version 1, and version 3. And this is really, I think, where Git comes in very handy and will help us to keep track of those and not having to do all these crazy copying moves we had earlier. The Software Carpentry has a nice little anecdote about Git and how it can be explained or maybe transferred to our daily lives, where we have like a document, and let's call it thesis for now, or like they call it final. And we write on this and send it away to another reviewer or maybe your advisor, and then there's changes to be made. So what do? Intuitively, right? You do those changes, and the advisor wants to see it again. So there we go. You send off final_ref2. And then your advisor says, oh man, no, not good enough yet. So, and you iterate over this, and this little comic right here gets us to final revision number 22, comments 49, and I can't even say the rest of it. Way too long. So, and this is, where Git would have been nice to use, where we can say, how do we kind of keep track of how we change documents over time? And the purpose for our Hack Week, for instance, is going to be how can we keep track of the code changes we do over time and not lose track in sanity because we don't know which document we were sending out last or currently viewing. And I think all of you probably have used, or maybe have used at some point in Word, where we kind of go through and can suggest edits. And this is kind of like almost the same idea that Git has as well. It will keep track for you what changed and what change made to that document. And then with those making those changes, it also remembers each one of those until and when you say, okay, commit, which is the command you will see and hear me over and over again, like git commit. Committing means this is a change that will persist over time, and then you will do many, many more commits. So commits is kind of a Git verb. I want to say that you will, if you hopefully use it going forward, say a lot. So, and this is how, I guess I'm going a little here over the Software Carpentry, how they explain it as well. So you see we have a document right here, we do a change, then we commit this change, and then all of a sudden we have a new document version where this is your committed change, and this is the difference in it. So what Git will do for you, it will keep track of all of these orange lines here. Now the power comes in again, where you say now we have multiple changes we do at different times. So we change the line up here, and we add 2 lines at the bottom. So then we have like a change for this and a change for that. And in the end, we then can produce one final document, as is shown down here, all of these changes being recorded as an entity itself. So then, for instance, if you would say, hey, what changed with this thing, it will only show us the orange thing. What changed with this commit, it will only show us the white purple thing here. And yeah, I guess they also say here, paper writing, you keep track of your changes. So this is kind of the concept behind Git, is that you always have just one document, but on that document, you will always keep track of the changes going forward as soon as you commit them. And key points, they say here, version control, and for us Git, it's like an unlimited undo we can do to a document. And it also will allow us as a community to collaborate on one document in parallel, only having one version then floating around in the end and not all the different underscores we see. All right, and also, I guess I forgot to post that link here, but this is here, the link that I want to put it here now in the Carpentry channel. This is where we're gonna follow along right now, and I'm going getting straight up into setting up Git right now, which is the chapter number 2 there. All right, so before we start using Git, we have to set it up. And the way that we do this is with the Git command and the shell. And if everybody, I encourage you to follow along here, types in now Git itself, it should give you this long output here where it says, all right, Git, I'm the command. And there's so many options here, and we will walk through a part of it. So like I said, first, let's set it up. And what we do here, we first give a name, which will be our full name that we want to identify our changes with. And also the email address, which it's going to be the one, or ideally should be the one you also used to register your GitHub account, because this is the way that GitHub, which is an online hosting service that uses Git, will be able to identify you as the person who changed it. Now we'll go in a little more detail what the difference between Git and GitHub is, but for now, let's just fly with the setting up the Git command, and then we'll get to GitHub in a little bit. So the first 2 commands I would like you to do and execute on your own shell here is those 2 lines here highlighted in the purple. This is configuring your username, highlighted here. I can increase my font size, I guess, a little bit. So here we have configure, which is the shell commands that HP taught us earlier. This is the command itself. This is a verb, what to do, and this is a parameter, like a flag. And in this case, you would say here git configure globally means for all the Git commands we're going to use going forward, it will be configured. And this is the variable, and this is the value for it. So I guess here, Mr. Dracula is doing it, but for us, we will be doing here a git config -- global. And then I encourage you to use the copy and paste and the right tab. User.name, definitely copy that. And then, well, I don't want to be Vlad, I want to be myself. And then it comes back with nothing. So this is a way of it saying it was successful. Can be a little confusing, but if you don't see an error message at this point, you're good. I can show you in a second how you confirm that you also did it. Second command we need to do is the same one as the first one, but now what we do is we configure an email address. So there, instead of you see user.name, we're going to use user.email. And one nice thing is also in the shell, if you want to see your previous command you executed, you use those arrow keys on your. Oh, you see a question right here. It's a good one. And you should use your full name, not your username of GitHub. This you should, for the user.name, should be your personal name. But going back to the little cheat sheet here for the shell, if you use the arrow keys and go up, you will see the last command you executed. So what I tend to do is a lot. I just go here, navigate to what I want to change. I want to change the email. And here, I'm just going to do my email address. And again, hit the enter command. And no error message, meaning good. So this command got executed. So how do we know what we configured? Git config gives also here us options to list them out. And you see, I didn't know what it was. But here I see it's the L command, which lists all of our configured variables. So let's use that. And here it is. So now I configured here user.name from earlier. You see my name, user.email, what I gave it. So this is basically the 2 setups you're going to do also, or you can repeat also on your local machine. This is, for instance, important when once the Hackweek is done and you want to keep using Git locally. I encourage you to also then use these 2 commands to configure it and set it up on your local machine. Now, the other last command or last line you see here is something specific to our setup here for the Hackweek. And maybe if there's time at the end of this whole session, we can walk over there. But for now, let's not worry about it. So let's see what else they suggest at the Software Carpentry site. These are kind of what we touched on earlier. There's different editors you can use to configure your terminal. But for us, I think now we're not going to go over those, since we have, these nice UI here and also text editor we can use. This is kind of the replacement we can use for this. And I guess they show you here what we just did with the -L. They use the --list command to show you what we just said here. This is the shortcut -L. This is the long option. So for Unix commands, you will often see like a short and a long version. And it does the same thing under the hood. Also, I think HP went over this earlier. If you ever don't know what command you just use for Git, there is either just typing it in, and it gives you an option, or the same prompt with the -H or --help. We'll show you here a short version of it, or the long version. Oh, I guess I do the same here. Anywho. Okay, but anyhow, so now we're set up with Git. So these are the kind of the two fundamental things you do. You identify yourself and you give Git the email address. So for every recorded change that you do with Git, it knows who did it, and it's identifiable and trackable for everyone going forward. All right, let's jump to the next chapter here. This Software Carpentry sends up onto a mission where we want to send people to Mars, Pluto, Moon, with Dracula. I guess we're just going to follow along with that. Oh, good question I see here from Anton. This is now, since we use the --global flag, this is a recorded setting. So it will not be, you don't have to do this again after you log in and log out of JupyterLab. This is now set anytime you're going to reopen a new shell. I can demonstrate you that. You see I have terminal 4 here. I'm just going to open a new terminal and type git config again. Here you see I opened a new terminal, but it still remembers my changes. And this goes back to the fact that we have here we used a --global flag, which of course I can't find. No, here it is. --global made these settings permanent across all of our sessions going forward. All right, so how do we actually now start the version tracking itself? For that, we're going to go through here a little example here. You have to tell Git to start tracking. So it won't just off the bat do it. You have to tell Git, okay, I'm in a directory now, and this directory I want to use going forward, and I want you to help me to keep track of those changes. So one command here that's also useful is clear. This will give you a nice clean terminal again. You can also hit your enter key over and over again. I guess it's old over time. So make dir, remember, this is how we create a new directory. And they want us to use planets. Sure, why not? Don't mistype it. Make dir planets. That pops up again here on the left. And now we go inside the planets. And this is where the git command now, or how we tell Git to start tracking everything inside this in this directory to be what's called a repository. Let's get started with the init command. So this is a once initial thing you do, and then from there on, you will not have to do this again. And it says initialize empty git repository planets. And the way that Git is able to tell that this is a directory that has changes that it keeps track of is this with a little special folder here called .git. Remember from earlier, dot folders are often used for configurations, and Git does exactly the same thing. So anytime you go inside a folder and you see a .git folder, it is a repository, what we also call it, that's being tracked by Git for changes. So this is what we just did. Basically, on the second slide here, we created our directories, we initialized the Git, so it knows, okay, going forward, I will keep track for you. And then it says, okay, here's the special folder .git. Let's show it as well with the ls. I think you have to do the A as well. That's how you do it. L, again, short for list. A, again, short for all. Our two special folders, ... and single dot, and here it is, Git. So this is how you know, is it as a repository that's being tracked. So here's our first command we will learn from Git outside the configuration, which is called status. This is a very important command, and then anytime I encourage you, if you don't know what is going on inside a Git repository, Git status will give you a very good message. I guess for us, it's right now nothing has happened. But if you ever were to go into a folder that you maybe come back to, or it's from someone else, and you just want to see what is the current state of this repository, just type Git status. It's a command that will do no harm, and you can do it anytime at any given point. So right now it tells you something about that you're on the master branch. Branching is a concept that you will hear more of during the Hackweek. For now, master is basically the main thing we are on right now that we are keeping track of, our master document, so to want to say. And there has been no commits. So it means it's a new directory and there has been no changes that Git knows of. And there's also nothing to change, which is the second line here. It says nothing to commit. And here it's a helpful kind of command by Git saying, okay, if you want to do something with it, you have to create copy files and use the git add command. This is something we will learn in the next couple of minutes here. All right, one important note also they point out here is places where we're creating our repositories. So once you are here you're inside our planets, everything from here on all the way recursively down will be kept track of. So for instance, if we would create more subfolders or other like directories underneath it, you do not have to repeat this git init command again. Since we're at the root level right here, and root level, I mean, is like the planets folder, this is being tracked off already. So it will do everything from here on downwards, no matter how deep, how many folders there are. So if I create 27 folders underneath this, all those 27 folders will be tracked by Git. And I guess they have a little exercise that I'm going to skip over for now, when you do have like they give the example that if you create it inside a folder, another folder, and initialize that, if you just want to get rid of it and say, okay, this was a mistake, just delete what we saw earlier, the rm command. You're just going to delete that .git folder in any subdirectory. Okay, so I kind of unloaded a lot from you, I think, right now. I want to open the round maybe for questions about maybe some conceptions or what we just did, or maybe people are still stuck on configuring. And give it like a minute or two right here, unmute yourself or raise it in the chat. Or I think I can't see if you raise a hand in Zoom, unfortunately, but yeah, maybe just open it up for some conceptual questions. So again, I also posted this whole tutorial I'm following along here from the Software Carpentry in the chat as well. And the two things that we did right now is we configured Git with us and defining us as a person. And we started to tell Git that everything in our planets folder we want to keep track of. So we haven't really done any changes, or we haven't added anything that we'll keep track of. We're just told everything from this folder on now is something that's being version controlled with uGit.
So I have a question.
Sure, if you
With
maybe
regards
just
to
could turn
Git.
up your volume a little bit, because I barely hear it.
Yeah, sorry. I have a question. So we're running this in the Jupyter environment,
Correct.
but what if we're running it locally? Do we have to install things, or how does that work?
That's a good question. So the Git command on the Jupyter lab or hub, so these are just interchangeably, we'll use it from now, so those mean the same thing, are we installed Git for you. Git itself is a software package that you can install on any OS. And for that, we have on our preparation, there is Git. And here we have a link to the software itself, where you can download it and you can install it to your local computer. And then from there on, since now you switch environment between the JupyterHub to your local environment, this is where you have to now repeat your 2 configuration commands that we did initially as well. But then again, it's like you do that once in your local environment, and then you're set up going forward on that machine using Git. Does that answer your question?
Yes, it does. Thank you.
Any other questions? That's the concept itself. It's a hard thing to kind of conceptualize at once when you get it unloaded from someone who does it over many, many years. So I will want to encourage you to really spread out everything you think that doesn't make sense yet, or maybe you will get a better hand of it, I think, once we do a little bit with it. And once you use it more and more, it will be really it will sink in more as you go along and use it a lot often. Okay, well, I guess there's no questions I can see in the chat. Let's then move on and start to track some changes. So now that we have our little planets folder right here, and it knows about it, that it is a repository, we can now start tracking or do our first change. For that, we go into our planets folder, which we still are. The way that the carpentry right now does a new document is by using the cat command, which is another Unix command. But since we have this nice little JupyterHub or Jupyter Lab, you can also just do a file here. Or also, if you first go inside the folder, you can do a new file there. That's the way I'm gonna do it. So here, an untitled new file. I'm gonna rename it to something they want us to, Mars. So let's use Mars. And then I think I showed this earlier when we started. I like to do now a split window, since it gives me both at the same time to keep track of. I'm gonna go inside my folder, and here you see Mars exists now. And there is also the Mars document open on the right-hand side. I'm gonna give this a little bit for people to get set up there. So next thing you do, so now we only have an empty file, right? We have nothing yet that Git will be able to track changes of, because it doesn't have any content yet. And that's one of the more important concepts of Git as well. Git tracks changes inside of documents. And for instance, if you just have a folder there, but there's nothing inside that folder, Git will not be able to tell that there's actually something happening there, because a folder on the file on your hard drive actually does not have anything it can track of. So this is something I will just keep in mind. Once you create an empty folder and then you say git keep track of that folder, it won't be able to do it because a folder itself, the content of it can keep track of, but not the folder, the kind of the encapsulation of it. And we'll sync it a little bit more when I do this in a minute. So let's add some text here. This is a planet or whatever your favorite sentence is in there. And now we have to save it. So now we have saving can be done either by hitting Control S or Command S if you are on the Mac, or you can also save text here, Control S. All right, and he comes back to the command I mentioned earlier. If you want to know what Git thinks of right now or its current state is, you can say Git Status. So this is a little different now from early on. Oh, I guess I have that. Let me get rid of this. I will probably come back to it later. This is something that is unique to Jupyter, and I think Scott will also cover that a little more tomorrow. IPy checkpoints is a folder that's internal, but let's just go back to what we need. So now you say git status, it has an untracked file. So this means Git identified that we have a new file in here, but it hasn't seen it before. And now it's wondering what's it supposed to do with this file? It's untracked. So in order for it to track it, we first need to add it with a command. And it's still, there's nothing added to if we would commit. Commit meaning if you wanted to now store a change to our repository or the folder itself, it will still do nothing because it doesn't know about it yet. So let's follow along what they suggest. This is what they say as well here in our software carpentry. We need to tell Git, I want to keep track of this document. So let's add it. Again, I'm also using the tab key heavily as HP, and we're adding the mars.txt. So now that we issued this last command, which git add, saying Git, keep track of this document for me, what's the status? So now we see it changed to green. It changed to be a new file, which are changes that are about to be committed if I would do so. So it hasn't committed it yet. It basically has put it on its radar to say, okay, this folder, which is a repository, now has a document that I'm supposed to keep track of. And the important thing is here supposed to, because we haven't done a change yet that's been persisted. So next thing is, now that we told it, okay, this is the thing I want you to keep track of, let's record this change. Like, let's record the state of the mars.txt and commit it. So there you say git commit. And here's one of the first things you will see, which is a command you probably will do over and over again. It's git commit, commit being record this change. And one of the requirements to every change is we have to tell or give a message or what has changed or what is this change identified with. So it's a message. And that was the -m flag is. It's -m means message. And now in two quotes, single or double quotes, both mean equal to the same. And this is a commit message that should help you also in hindsight to keep track of what just happened with this document. So I will just say added new file mars.txt. And this is a way I tend to do things. There's many different philosophies behind how a good commit message is constructed. But for me, I usually like to tell things what I did here. So I added a new file and it's called mars.txt. So and if you add that, you get this little output here, which is a little longer than before, which gives you something back that is a unique identifier. So this number here, it's also called a Git SHA. It's the unique identification of this change. It repeated what I just gave you, or gave Git as a commit message, being added new files. It said, okay, this change where I created an internal number for me being Git, identifying this change. What you gave me as a message, it's one file. There was one insertion, which is the first line right here. This was just one line. And it's this is what you're also going to see in the shell here. If you do the ls-l 644 is basically, it also remembers what were the permission rights to this file. So this is 6 being read and writable, 4 is readable, 4 is readable. So now we have this file with its privileges being stored in the Git repository. See, someone's typing a question. I'm giving it a second. Why does it show 0 insertions? So when you added your line to the file, did you also save the file? So if you, for instance, would do a change, you see there's a little dot up here, meaning it has unsaved changes. If you save it, it goes back to an X, meaning it has these changes persisted. So this is something you need to keep in mind when you use the terminal and the editor side by side. For it to be recognizable by Git on the terminal, it needs to be saved first, and then you can commit that change. Good, I see a thumbs up. So now that we have this one file, one insertion made, we can go back to Git Status. It will create this folder over and over again. Let's ignore it for now still, but you see our new file mars.txt does not show up anymore. So it means that now it's part of Git. It has been committed as a change. And as of now, Git knows about it as it is with my one sentence right here. We're in branch master and planet. This is a plan. This is a sentence. This is the content of the document that Git knows about. So the next question you're probably going to ask yourself after you issue this command is like, where are these changes now? Or how, better say, how can I know now where it's stored? So these changes itself are stored inside the special Git folder that I showed you earlier. And this is also something, a folder that I would not mess with, just a heads up there. Like this is something really that Git takes care and maintains itself. But long story short, this is where it also then does this, where it knows, okay, we added this file, track this change, we committed this content, track this change. So all of this will be handled inside the Git folder by the Git command. All right, well, I guess now it wants us to go in and says, let's modify the file and see what happens. Let's go ahead here and do exactly that. And we're gonna say somewhere here. Not very creative, but it is a change. So now we have, like you see, the first line, this is a planet, and we have a second line, which is somewhere here, which is line number 3. So let's see what happens now with our Git status command. Oh, this is new. So you see beforehand, we had a new file, we committed it. It was good as of that state. But now since we added this new line right here, it says changes not staged for commit. This is a concept I'm going to introduce in a second here. but it was modified. So the important line here I want to take away from here is it's a modified file where Git says this is different from what I stored under my Git folder versus this is something that you have right now on your file system. So you see here, it also says it's modified. And it says, so what changed? So can we make a comparison? Can we find out what changed in the meantime? Because, you know, this is right now is pretty simple. We only have a couple lines, but what if we had like multiple hundred lines in there? So again, say git diff. So since Git knew about our initial state, what we did earlier up here, and now we changed this line, it compares what it knows to what it doesn't know. And it says right here, document A is the one inside our repository, and document B is the one that's right now on the file, like what we see right here. And it says, hey, you added a new line that is called somewhere here. And you might be wondering, why does it also show this line here? If you recall from earlier, we had like a line that ended right here. And internally, a file also has to introduce a new line to get to the second one. So that's why it also shows, look, this line changed from this to something that also had a new line at the end. So right here. So now that you know, okay, this is the change I introduced. Do you want to keep it? Well, let's find out. I guess Software Carpentry said, yeah, we're happy with it. Let's also be happy and say, all right, so what's now the way to say, let's add this change to our change set of the file. And the way you do is you do not have to do git add again. As a new file, you should do git add as a change to the file, but it's basically the same thing, right, saying here. You see, git add in this case will do add the changes to the file that we did to the history. And once we do that, we go back to our status command. And now it's another message saying, all right, you said, okay, you want to keep this as a change. And it's now, again, this two-step process. So this is something that is the flow of Git, where you first say, this change is good. I want to add it to a recorded change. And then you will see it again in the green line as being modified and changes to be committed. So what I really like about Git is it really is very verbose and also tells you what's going on or what the status is or what you could do. For instance, you know, you said you change this not stage from commit, use git add to update what will be committed. This is what we did here. And then once we did that, it says, okay, now that you did this, now if you want to also record that change, commit it, then you use the git commit command. Or if we say we don't want to do it, you can say git reset head. And this is also something that's confusing for people at first. When you say git reset head, it will not just throw away this sentence here. It will just put it back to the stage of where it says, okay, it's been modified and not staged for commit. So git reset as a command, I guess we can just do it right now. You see, it's git unchanged, and over here, my sentence is still there. So it's kind of a just for Git itself to say, no, I don't want you to do this commit with this content. Let's take a step back instead of saying, no, just throw away this change of this file. I don't want it at all. I want my file to be as it was before, as I've never changed it. So there's an important difference here. Git resetting head here means only, no, this change is not ready to be committed. Let's go just a step back. But before we do that, let's first do another change so I can show a little bit more about the history. So let's add it back in as we did before. have a status, and now changes to be committed. And again, I'm going to do it with a, say, updated March. The 3 insertions is referring to what we saw earlier here. 1, 2, 3 lines. 1 file changed, which is our march.txt. The deletion refers to that it removed this planet line with the planet line that also had the new line character. All right. So now we did it. We had like a second change to an existing document. And this goes here. This picture is what I was trying to get earlier with the staging area of what is different between I want you to add this change to my next commit versus this is a recorded change. This is what's been highlighted here. Okay, I see someone, there's a question. Let me quickly see if that is something that potentially people or more people could run into. It says, okay, git commit -m, nothing to commit. Oh, let's go over it again. So this goes back when it says nothing to commit, that in the staging area right here, there was nothing in there. Meaning, although you made changes to the file, you didn't tell Git that these changes to the file itself are something you want to commit in the repository. So to go back here a little bit, git add is basically the command that will add it to the staging area. Git commit, with the message you give, is basically it moves from staging to the repository as a recorded permanent change. So this stack here is permanent and being developed as the history of the document with individual changes it keeps track of. This here can still be undone without saying, okay, it's going back to my history of the document. You can go back and forth between this, and Git will not record a change where there's no little number right here and your message you gave it. But as soon as you hit the git commit command, you will record a change in time into the repository. I see another question that says here, so is it always a two-step process of first add, then commit? Do you ever commit without adding first? So yes, to the first question, there's always the two-stage process of saying first add, then commit. And you could not, the second part of your question is, do you ever commit without adding first? Git would not be able to commit a change without it being added. And the reason for this is, if you think a little bit bigger, so right now we have a very simple repository that just has one file. And we think about it now as a term of a code base, where we grow the code base over time. We have many, many, many different files, or we have like dependencies. We change something in this file that also causes code to change in another file. And at the same time, we were at it and also changed this file and another one. But these are two independent changes. So in reality, if you want to keep it like concise and as a whole, you would first commit the first set of changes, and then you commit the second set of changes to make them good as a whole. And that's where the git add command is so powerful, is although you had many, many changes going on at once, you're able to say, I'm going to cherry pick the one here and the one there, make this a commit. So git add file 1 and 2, commit it, and then you have number 3 and 4, say another third and fourth file. Then you add 3 and 4 and you commit that change. And there are now two individual changes that are independent from each other, because it makes sense to separate them for instance, some code reasons or logic reasons. So maybe that helps a little bit why there's a git add versus a git and a git commit versus just commit everything. It helps you kind of over evolution of your changes to say, all right, these two changes belong to each other. let's add these two and make it one. These two changes belong to each other, so let's add those two and commit them. So basically, if you had more than one document, compose a change set as a whole that makes sense, and then commit it to the repository. I hope Ross that answered the question. Cool. All right, so let's see what our second change did, just to see the evolution of our document. So if I now say go back to git diff, there's nothing there, right? Because we just committed our changes. However, if we use the git show command, will show us the last change we did. So git show goes always back to the last one. It says, look, here's our message we gave it, update Mars. And where is it? Up here somewhere, I guess. This is basically the commit message I gave it. And of course, now I can't find it anymore. But I guess hopefully you trust me there. And again, this is this short number, or like this hash, as we also refer to by Git, that keeps it track internally. And it shows, all right, we changed the line from this planet to the line of this planet, an empty line, and somewhere here. Git diff itself, because now it for Git, this document itself is known as is, does show nothing, but git show, which is the show me the last change I did, shows us something. Okay. What else do they go through here? I guess that's also a worthy one. So here's one they say git -- staged. So let's do a third change. Let's add or else as a question. So now let's do our usual flow, right? We have a document, we changed it. It will show now up as being different. So git diff is another command where you can say, okay, give me the changes that are current in this document. And git status will only show us that this document as a status changed. And git diff shows us now the actual change to the document versus what it knew from the past in its repository. So now if you say git add, it's gone again. So what now you say, okay, I don't even remember, I added this document so many times now, and now I'm ready to commit. So what really actually changed in this document? I don't even remember everything. This is where this -- staged command came in. Because remember now here, we have this staging area that we just added all of our changes to, that it's about to commit. So it's not a permanent recorded change. It's something that's about to be recorded. This is where you can use this command, git diff -- staged. And look, it's the same command as if I would just show a diff from a committed change, because you see it's like it has these two indices. And here, though, it's still not permanently recorded, it's still modified, but I can still inspect it, or I can inspect what I'm about to commit. So the -- stage basically tells Git, instead of looking into the repository what changed, look into the staging area what changed on what is about to be committed. So let's also just add this to our repository as a recorded change. Let's do a commit. Update with question. And so now if you do our -- staged, there's nothing staged because, it doesn't show up anymore as being modified. But if you go back to the diff, oh, well, the diff is it's not being changed on the currently from the repository versus the file on in its on disk, but Git shows the command. This is what I wanted to show you, where it says, okay, now here we change this line. So this is the recorded change. I hope that made sense. I know it's a lot of kind of different commands going back and forth, but this is the important takeaway from this kind of exercise right now. We have a document being tracked off by Git. You change it. There's still a separate area where you can do changes all along, and you can pick and choose of changes. And then once you're ready for these changes to be a permanent recording, you commit it and you have it recorded as is. All right, so now that we did like 3 changes, and we created a history of a document, and we just don't want to go back 1. We want to see more than that 1 change. We want to know what is the entire history of this document and the evolution of it. This is where the git log command comes in. So let's do it. Git log, and this will show you now the entire history of this repository as a whole. So this repository would not just have like Mars, but there's like Jupyter and other plants and different documents. All of these changes to all of the documents combined will show up with this command. And here it is. So we said git log. Let's clean the screen and do it this way. This is the evolution or the history of our document. We first added the document back then. We updated Mars with ours somewhere here, and then update with question, which was the last one. And here's also those numbers come back. First, we had, like, this is the unique identifier for this change, unique identifier by Git for this change, and we have it on that date as a human readable. And also what we configured earlier with a -- global, our name and our email address. Quick time check here. We have 12:50. I think. Let's do one more. I guess I show you also different ways of how you can customize this log. Let's just go over them, because sometimes, when you have like a repository that has a long history, this will fill up your screen very, very fast. So now you can also use this -- one-line option here. It's almost like the same as with many Unix commands. Look into the options and see what they have, if they do a better fit for your purpose at this point. Because we can also just show like the short number we saw earlier, because when we commit our changes, it always gives back those short numbers instead of this long one. So this is what's showing up here. And also one important part about how to read this log is that head always means this is the most current. So this is as of what you see right now in your repository, and masters is the branch. And like I said, this will be a concept introduced a little later, or maybe only in the Hackweek itself. This is basically your branch name, master, the main tracked change. What else? Oh, they also give you a graph option, but I don't expect to come out any different, but let's just try it. Yeah, so here you see now it adds basically a star. And this means all of these changes are happening on the master branch. So if there would be multiple branches, again, there would be multiple kind of tracks coming up. But since we keep it for now simple, we want to keep only one master branch. So that's why I would say if you have all of these changes happening right here. Okay, coming to the last special thing I want to cover, I think, before we're going to go into a Git log is for all the chain within a track directory or just single documents, or can it be aimed at a single file? Okay, good question there. So Git log itself, as I said right here, will be for the entire repository. So it will make a little more sense if you add more changes later and practice and add for different files. And then you will see all the file changes you did with this command right here. So git log with no parameter will give you the entire history of everything that's underneath this directory. And if you want to see more options here, oh, no. Now I have to find myself this command. I thought Git had also just a help for log specific one, but I guess it does not with this version. Ah, there it is. So it's the only short what's for -h. So if you now want to show just for a single document, you can give it a path right here. And this can also not just be a document, but also for a directory. Now it will show you only those changes for this given path. I'm still reading in your question, because I think this is very helpful for other people as well. But yeah, so again, if you wanna, if you don't know what options are for a command on the Unix command line, look for the -h. -h is a universal kind of helper, or a agreed upon standard among the Unix community to say this is always displaying help. There's either the single or the, like I tried before, -- help. So myself, you know, if I sometimes don't know what's going on here or what options do I have, I just try these two and there's no harm again trying that. But anyhow, it also, there's a lot more going on than they show right here. And then there's also, I want to highlight for helping or documentation, there's always online as well with the Git command where they have a lot more variables. But anyhow, going back to the initial question here, git log for the entire repository, git log with a path being a file or directory will show you the history for that specific area. Okay, they want us to add a second file here. And what I also want to choose here is this kind of confusing, first of all, concept about Git not being able to track directory, it seems. So let's walk through that. And if you remember, make dir makes a new directory. So let's create a new directory called, I don't know, rockets, because everywhere. Hopefully you like rockets. So now you see here, rockets itself is a directory. And you can also identify it with the D. So without a D, you see it's a file. With the D, it's a directory. It's also showed up here on the left-hand side. But now if you go back to our Git status, it doesn't show up. So what happened? So this goes back to the concept that I was trying to explain earlier, that a directory itself doesn't have content that Git is able to keep track of. So, you know, Git is good as we are, right? It knows how to read this text here. And this is something you can track over time how it changes. But if there would be nothing inside there, you would not be able to tell what changed. You know, you maybe be able to say the file name changed, but this is another level of Git that's beyond the scope for today. This will be a new, completely new change set. But it needs something to say, okay, I'm able to keep track of it as how it evolves and changes over time. So the important thing to do there is when you create a folder, and you probably create this folder because you want to create a separation, or you want to do an organization, you need to add a file, which I'm going to just do now here and call it number 1. So now if I type my git status command, it says, oh, /. What does that mean? So basically, since I am inside now my rockets, it says this current place you are in right now is not known, but I know there's something going inside there I can potentially keep track of. So if you go one up again, there you go. Now you see it knows about rockets, but it doesn't know anything about inside there because it hasn't been told to keep track of, but it can identify the file in there that it's able of being tracked off. I hope this kind of makes sense. It's kind of a harder concept to get once you start creating folders inside Git, but you need to give it, first of all, something to keep track of. And once it identified the thing it can keep track of, it wants to keep track of everything where it's located, including the folder. So now if we add this file, this folder here, we can just add rockets as the folder, and everything that we put inside this folder right here, it will keep track of. You don't have to go individually to go through all of it. Because there you see, now Git knows about rockets, and if there would be another file, it also would give that file too. So, but this is how Git is able to identify it as being a change, is you have to give it for a folder also content to a folder so it can keep track of that. So let's just add it. So we still already did the add, and let's do a commit. The rocket folder. And here again, goes back to one file. It has 0 because we only gave it an empty file. So it's able to keep track of it as an empty file itself, because now it knows, okay, it can grow over time. We'll look at it. Let's go back to that log example we had earlier, right? Because now we have a little more. You see, we added the rocket folder. We had the marsh.txt. Git marsh, I guess this was hard to see. Git marsh.txt only shows us the 3 changes. And let's put some meat in between here and now say git log. But for the whole repository, we have 4 changes. So this is how you kind of grow and evolve your repository, by adding pieces at a time, and every change you think is good as a whole and you want to preserve as a recording in the history, you add it and you commit it. So now we have a Git rocket folder and or the changes to our Marsh document growing over time and persisted with Git. What do they cover here? I guess where we already said, the -m command gives us the option to give a message. One thing I guess I want to highlight before we go into this little exercise here, which is called bio at the bottom. So I'm going to post this change here. But before we do that, there might be something you potentially can run into, and I'm going to just show you right now how to get out of it, because it causes a lot of confusion sometimes. So let's add a change to the number. Say it's the rocket number 1, right? Save it. So it's persisted on your file. You're going to see, let's do the dance, Git status. Look, it's modified. I'm adding it. This is how you add only a single file. So for instance, we have multiple folders we don't want to keep track of. Git add rockets number 1 txt. Now it only added this one. So now if you ever happen, you're excited, you type it too fast, you hit git commit, what happened? So by default, if you don't give a -m as commit message, Git will open up an editor, because Git always needs a commit message. It will not let you commit a change without a message. And then Git goes around and says, okay, let's look at the default editor that is configured with me. And in our case, our JupyterLab environment is configured with VI. It will jump into the VI editor. VI itself is a program that it's on the machine as a command. I can demonstrate it that way. Let's just open another terminal. So VI here is an editor. So it's called Vim also sometimes. So anything basically you see inside here is as you opened this document with VI. And the thing to remember, if you are new to Linux or this environment or the VI command itself, the way to get out of it is you're gonna hit colon, which you see at the bottom down here. So this is kind of where the axe is gonna hit now. Q for quit, but you also have to give it the exclamation mark because you want to just exit VI as is without doing anything with it. So this is a sequence you probably want to remember if you don't want to ever deal with VI. But now you also see aborting commit due to an empty commit message. This is what I was saying just earlier. Git always wants a message. Git always wants to have you something recorded with your change that it's identifiable for you as a human, because we humans don't like to read cryptic numbers like these ones. So this will get you out of it. Let's repeat this because I think it's worth mentioning right here. Git commit, you're in the VI editor, you just want to get out of it. Colon Q, exclamation mark, and you're out of it. And now you can go back and say, updated rocket doc. And you are back as we saw it earlier with our standard workflow. Here's our change. Okay, so that was a lot. I hope you kind of were able to follow me. Before we go into this bio exercise and different breakout rooms, and we'll give you, I guess, happily can say like 20 minutes, a little more than usual, because it's a lot to cover. And if you're new to Git as well. Are there any open questions or something you would like to explain further before you start to? So the task will be, you're going to start from scratch again on your home directory right here to create a folder, initialize this folder as a Git repository, add one document, change it, add a second document, and change it. I think they even have a challenge there. Let me verify that. Yep, display the differences. This is an added challenge. So if you don't get to that, don't worry about it. I really would just want you to play with like these 3-4 steps to say, make this a Git tracked repository. And then really mostly what we also just did here as a walkthrough, add changes, experiment with the log command, experiment with the diff command. And again, if you ever see these IPy checkpoints, don't worry about them, like just ignore them for now. And if you're stuck with it, feel free to raise your hand. That's something that's very specific to the JupyterLab environment that we will explain further tomorrow, or if not tomorrow, for sure at the beginning of the hack week. So any questions? Ah, that's a good one. And HP just raised a very good question about any guidelines on file sizes and Git repos. We don't want big data sets in there, correct? Correct, yes, indeed. So Git, so as you saw, what Git does basically is try to make differences between files. And now imagine yourself, if you have a massive file, say a couple gigabytes, and you keep checking it for changes and also then committing those changes over and over again, your repository will grow very big over time. So it's a hard, like really to give there a good guideline, but say anything in the couple of megabytes is probably not a big deal. If you start to see double digit in your file as in megabyte file size, I would start to think about maybe alternatives or maybe not use Git for it. And also another thing along the files. So you see we use text files right here, which are very easy to keep track of and change. But then, for instance, if you have a binary file, and in a binary file, I mean, for instance, a JPEG or like an image, an image, you cannot get the differences out as we do right here to see, we have a line, we remove a word, everybody knows how to or it's very easy to see, okay, the word has been removed. I'm just gonna keep track of this word that's been gone and store this as like a change. If you have a binary file like a JPEG, there's no way to say only remove those 5 letters. It has to take the whole thing as is because it identified there was a change to this file. It will store the entire thing again. So then, for instance, if you have one image and you store it or change it 10 times, you will have 10 copies of this file in the repository, and it will grow very big and very kind of unwieldy fast. So yeah, keep it small if you can. Text files, no problem. Binary files, or for instance, data sets, I would not recommend.
Along those same lines, Joe, let's say I make 1,000 commits on a small file. Will Git run out of memory? Are there any limits on that?
I have seen Git repositories with thousands of commit to thousands of files. So my prime example is if you ever use the tool called gdal.org, and look at their repository and look at the size and amount of files they have and the history. It's a program that has been now for over 10 years. Or another anecdote, the Linux environment you're using right now, Linux itself was actually the reason why Git got created. So the author, Linus Torvalds, was tired of the existing ones. So he created Linux on basis of Git and keeping track of changes to all the files and logic that belongs to Linux environment with Git. So if you can challenge to get Git out of space and out of numbers, I think you should let him know, because he will probably be very surprised.
We had some great conversations in the breakout that I was in, Joe, and one of the questions that came up was, how often should I commit? What's the sort of frequency? And just sort of, I talked a little bit about, there's a bit of an art to it, but do you want to give us your reflections on that? Yeah, definitely. So that's also one of those things, I guess we can go fill a whole session about it. I like to think, as a change that is something that I would, for instance, like to come back to and see what I changed that's easy to digest and also kind of makes sense. To give like a specific example, you, like I said earlier, you have, say, multiple files going on and you change something in, say, 3 out of the 4, and every change to this file, can live by itself. It's like, it can be also, for instance, reverted and doesn't break any other logic if it's a code piece, for instance, and can, like I said, live by itself. So I like making small, and as Anthony also asked earlier, there's no harm of committing as much as you can and creating like a really like an evolution in the history to your repository as a whole. You want to see it evolve, you want to see it change, and think about also if you would go back there, say in a year, and you want to just give me just the changes to this one like commit you did. It's like this one SHA, it's like this short acronymic number there. And when I read it, can you understand it again, Or do you have to browse through 15 files you change for that commit, and it's just all getting kind of tangled up and you kind of lost yourself? So I always say, commit often, commit frequently, make a whole change set that is complete. For instance, that doesn't break software. If you have code, you just changed a function, say, and a function parameter, and then all these functions, all the other places you call this function, you update those. That's for me, for instance, is a nice change, right?
you change the method and all the places you call that method, commit it. And then maybe you want to improve the method, right? And say, now I want to be more efficient, have another feature. That's another commit, you know. Some people like to do like rename it all at once and improve it. I'm encouraging to say, first rename it, commit it, improve it, commit it. And then, you know, it's like easy to come back to and to say, it makes sense what I did there. And I can also explain to you in a year, this changed this much, and this is what it did. Are there any other questions, or maybe best practices principle? I mean, we have now another, just for time bias, like maybe 10 minutes-ish, I was thinking, since we already had all a long day, and I'm gonna do just a quick, what is Git versus GitHub? And then show you that. I'll explain it to you, and maybe do another something called the Git clone. And that's really about it. So we have really room here to open up for discussions, or maybe here's something you shared in or found your group that was pretty interesting. All good? Well, okay. Let's wrap it up then with the last piece for today. And I'm gonna start sharing my screen again. Where is my screen? Quick harder. All right, there it is. So now I'm still here inside my repository as I see git log. You know, as I said earlier, if you want to check, is this really a Git repository, and you find your magic.git folder, then you know it is one. So now we created, you know, a repository that's only local to our computers. But say, what if, for instance, we want to now work with someone else that's some other continent even, and we want to share this. So if you would just take now this folder as is, copy it, or say package it up and send it across in the email, that's not really what Git was intended to design. And also it would defeat its purpose, because now you would basically, if you go back to the picture about tracking changes, you would ship him this whole repository by itself. So he could do changes with it, but you wouldn't know about him, because then he would also then have to package it all up again and send you it back. And kind of this is almost like with the entire history, it's very inefficient, it's cumbersome, and you know, there are things that can go wrong, you know, when you have the Git folder inside there. So the way that it's most kind of common practice here is via GitHub. And I don't know if I tab open, but it's easy to open one. So GitHub itself, as we know it, and let's go to say SnowEx website. So GitHub is basically a web service, like what we use everywhere in other places in our daily lives, that is built upon Git. So what GitHub is doing, it uses Git underneath it to publicly host these repositories. So instead of the name website, you would, for instance, see a folder called planets, because what the website is, and what we worked on, you know, before we showed it to you guys all, is collaboratively on this website between all the kind of team leads and tutorial leads and everybody who got involved and committed and did what we just did in a like shared collaborative environment. And the way we kind of got all a copy of this website repository without, you know, everybody getting a big zip file in his email box is by using what's called the git clone command. So let's go, most importantly, outside of my plans folder, because otherwise I would put a repository inside the repository, which, you know, is double duty and wouldn't do us any good. And so now I'm here in the plans folder. You see it right here. And I can just issue now a git clone. So if I just do this by itself, clone basically means give me the current state of this repository that is on GitHub and copy it down to my environment. And in our cases, it's the Jupyter Lab. But you could equally, for instance, also do it on your local computer if you want the Git command installed there. So basically it says clone, copy this publicly hosted repository onto my computer. And the way we do it is they have a nice little button up here. And let's step one back here and just use the learning Git, because it's something I also is part of our preliminary for the hack week itself. Wait a second, not this one. Setup check. There it is. Oh, let me think about this for a second. Not yet. Let's go and learn Git. Here it is. And then use this green button up here in the top right corner. So there you see you have the HTTPS option, which I encourage you to use. And here's a little clipboard. So you're going to copy now the URL of this learning Git environment. Go back to our Jupyter Lab. Issue a clear, because we like to start with a clean screen. And now we say git clone. And again, importantly, make sure you are on your root environment at home Joven. And one nice little shortcut, if you just type cd without any commands or any arguments afterwards, it will put you right there. It's kind of a nice shortcut. And if you see me working, you're going to hear me a lot typing cd, because I always forget where I am at. But anyhow, go back to git clone. So basically git, give me the repository of what I just copied. So you see there has like a little .git ending in here. And hit it. So now cloning, as I said, it's copying. It goes out to SnowEx Hackweek site, and it copies it down as a repository. And it should up here in a second. Here it is. And now let's go inside there. So you see here's again our magic Git folder that keeps track of all the changes. And now to show you, if I would go say here, 46 commits, here's all the history that has happened on this repository. And this is the same as if you would now issue a git log command. You see, our tool was here last committed right here 4 days ago. Let's see if that happens 4 days ago, June 17th. There it is. So now you basically have a copy as of the state of today where you issued that command of the Git learning report. And now, you see we are kind of have a longer history here. So, and we're not kind of getting out because it's very long. And the way to get out of this is just by hitting the Q command in your terminal to get out. So you see now I'm back into a prompt. So this can be sometimes confusing. If there's a long history like this, so you can scroll back and forth with your arrow keys. The way to get out of this is just by hitting Q. And then if you also say Git Status, we are on the main branch here. Nothing happened, nothing to commit. So basically, now we know this is the copy as of when we issued the command. If you would say, for instance, touch a new file, we go back to what we tried and practiced earlier, also with our little exercise. Now we have an untracked file, and you see it's not known. And origin main basically tells us origin is the one where we copied it from. So the original source is not up to date to what we have locally down here on our JupyterHub. There will be a little more about this during the week and during a hack week. And we also you're gonna practice this a lot in the actual hack week. There will be another tutorial about this. But I just wanted to kind of now wrap this up today to show you, okay, how can we now collaboratively use the evolution of our documents, collaborate with a lot of people around the world and then also go back and forth. And the way you push your changes upwards, like I said, that will be covered in the SnowEx Hack Week. But for now, I just wanted to give you the kind of little big picture here. Git is the command that allows us to create history and record history and go back and forth. And then GitHub is kind of the portal on the web that allows us then to collaborate, work on these repository, commit and push changes. Like the workflow will all be the same. And then there will be one last step I will show you in the Hack Week to put it up there, and then people can copy it down. And but yeah, I think that is probably a lot to digest as a Git intro. I hope it all made sense for you, and I hope you guys could follow along a little bit. Feel free really also to use the chat, follow up with questions, or yeah, if you have anything that needs reiterating and explaining again, I really encourage you to use that chat and also answer questions if you can explain to someone else, because that's also a good way to learn, right? If you got a concept and you know how to explain it, or feel confident how to explain it to someone else, I think this is also how it sinks in and how it will help you to get a better handle on Git. But yeah, so with that, I guess I'm gonna pass it off for Anthony, with a couple minutes left for wrapping it up.
Hey, yes, thank you. Let's give a round of virtual applause to HP, to Jane, to Joe, to Scott, to Evie. Did I miss anyone? I think that's everyone. Thank you so much. Really learned a lot today, and just appreciate all the time you put into teaching us this content. We've had some questions about the video. Jane will send me the link to that. I'll put it up on the website. I'll put it in our chat as well, so that you can come back. Encourage you to use that as a resource to go back and maybe work through parts of the tutorial that might have gone by too quickly, or you want to revisit. Keep on putting questions in our Slack channel. We'll still be there to answer things, especially between today and tomorrow. And tomorrow we'll start at the same time, 9 a.m. Pacific. Scott will be guiding us through some of the basics of Python. And I'm happy to hang out here, stay in this space to continue chatting. If anyone has questions, or even general wonderings about the Hack Week coming up, we can kind of make it pretty informal. If you need to get going, that's also fine. So thanks everyone for your attention today. I know it's a lot of content. We'll look forward to seeing you back again tomorrow.